In this video for section 14.1, we're going to start talking about how we examine the relationship between two quantitative variables. So in chapter 13, we looked at the relationship between two qualitative variables, and we used the chi-square test for association in order to analyze that relationship. Now we're going to be looking at the relationship between two quantitative variables, which means that they are numbers with units. So we can represent this relationship visually with a scatter plot. When we make a scatter plot, we put the dependent variable on the y-axis. The dependent variable is the one that we want to explain, and the independent variable goes on the x-axis, and that's the one that is doing the explaining. So one way to think about it is to think about a potential cause and effect. Which one would be the cause and which one would be the effect? Now, it doesn't necessarily mean that there's a cause and effect relationship, but if there were, which one would be which? And so here we have some examples of scatter plots. We have a positive linear scatter plot and a negative linear scatter plot. So the lines here are not exact lines made by the points, but you can see that the points are more or less making a line. And remember from algebra, slope, when you look from left to right, is positive in this graph, and slope, when you look from left to right, is negative in this graph. And so when we're talking about positive and negative, in this context, we're talking about slope. We could also have points that follow a shape that is not exactly a straight line, and that's called curvilinear. So it could make more of a parabola type shape or an exponential curve, something like that. That's not a line, but it's still some sort of pattern. We also could have the dots or the points having no relationship. So they could just be scattered around, like this picture here, or they could make more of a horizontal line shape. That would also mean that there is no relationship because y does not depend on x. X could be any value here, and y is still going to be in the same spot. So we can calculate something called the correlation coefficient, which measures strength and direction of the linear relationship between the two variables. Correlation coefficient is a number between 1 and -1. The correlation coefficient is 1 if the points fall perfectly on a straight line with a positive slope, and it's -1 if the points fall perfectly on a straight line with a negative slope. Correlation coefficient is 0 if there is no linear relationship between the two variables. So that would mean that the points are scattered, or it could also mean that the points have a relationship that's not linear. The closer that r is to 1, the more closely the points fit a straight line. So our values of 0.8 and 0.9 are going to look very much like a straight line. The points won't be exactly on a straight line, but they'll be pretty close. And the closer r is to 0, the more scattered the points are. So an r value of 0.1 or 0.2 is going to look pretty scattered as far as the points go. So we have some examples here with example r values. We can see that an r value of +1 means that they fall exactly on a straight line with a positive slope, and an r value of -1 falls exactly on a straight line with a negative slope. An r value of 0.7 means that there's sort of a positive line here that you can see, but it's a little bit more scattered. And an r value of -0.55 also sort of follows a negative line, a line with a negative slope, but not exactly, and the points are a little more scattered. And then we have these examples of r values of 0, where the points are not following a straight line. So we can use a formal hypothesis test to determine whether there is a correlation between two variables. And this is what our null and alternative hypothesis will be. Remember, our null hypothesis is equality, and our alternative is inequality. So our null hypothesis is that this fancy p equals 0. This is actually the Greek letter rho, and so we use Greek letters sort of that correspond with their corresponding Latin letters that we use in our alphabet. So r is correlation coefficient. The Greek letter rho matches with r, and so that's why it's this funny looking p. So rho equals 0, which means there is no correlation. Our alternative hypothesis is that rho is not equal to 0, which means there is a correlation. And so we can calculate the p-value in Minitab as usual, and then we decide if we reject or fail to reject the null hypothesis based on that. What you need to remember about correlation is that it does not necessarily mean causation. So for example, there's a strong positive correlation between number of shark attacks and ice cream sales in a month. Does the possibility of shark attack cause people to buy ice cream, or does buying ice cream make people more susceptible to shark attacks? Neither one is true. They both increase in warmer weather. So just because there's a correlation doesn't mean that one is causing the other. There could be a hidden variable that is causing, in this case, it's the fact that warmer weather causes increases in both number of shark attacks and in ice cream sales. So we're going to look at this example where we have a company that supplies soft drinks and snack foods to convenience stores in Michigan, Illinois, and Iowa, and the company wants to know whether there is a relationship between sales and number of years with the company. And so we want to determine the correlation coefficient and test it for significance. So here we have our data. We have our salespeople, and we have the number of sales and the number of years that they have been with the company for each salesperson. So what we are going to do first we're going to look at a scatter plot. And we can make a scatter plot by going to graph, and then you'll see the option for scatter plot there. We just want to click on the simple one and then click OK. And then we are going to have to decide which one we want on X and which one we want on Y. And so the idea here is that we're thinking that the number of years with the company is going to be the cause and the effect is going to be how much sales they have. So maybe people who have been with the company for longer are going to have more sales because they have more contacts and things like that. Or I guess it's possible that they could have fewer sales as well. Maybe they're involved in different projects more and have less time to spend on sales. Either way, I'm not sure, but I'm thinking that the years is going to be the cause and the sales is going to be the effect. So that's going to be my scatter plot. Click OK, and then it's going to give it to me here. So here is my scatter plot. Make it a little bit bigger so we can see the whole thing. So when I look at it, I can kind of see a line with a positive slope. Obviously not exactly on a straight line, but when I look at this here, I can see a line with a positive slope. And so what we want to do is we want to calculate that correlation coefficient, or that R value. And so the way that I do that is I go to Stat, Basic Statistics, and Correlation. And then in this box, I'm going to put my two variables. Now, it doesn't matter what order you put them in, actually. The correlation calculation is the same. So I'm going to click on Sales and Years with Midwest and put those in the variables box. And then I'm going to click on this Results box and check the box that says Pairwise Correlation Table. I need to do that in order to see what the p-value is, if my question is asking for the p-value. So check that box, click OK, and then click OK again. And then it's giving me here, again, it's going to give me a scatter plot. This time the scatter plot is going to have the R value written in it. So I see my R value here of 0.833. So that's a fairly high positive R value. So that means it's a pretty strong correlation and positive slope, which is what we thought based on the scatter plot. And if I keep scrolling down, I see the correlation value kind of in its own separate table there, 0.833. And then if I keep going, I see the p-value here of 0.001. So I'm going to write those down. So I found my R value of 0.833 and my p-value of 0.001. And so when I'm using my p-value, again comparing it to alpha, I get 0.05 for alpha, so p-value is less than alpha. That means I reject my null hypothesis. And I didn't write my null and alternative hypotheses this time, although I probably should have. But here are my null and alternative hypotheses. It's really not going to change here. This is what they're always going to be when you're testing the R value or the correlation. So my null hypothesis of no correlation, I'm rejecting the null hypothesis, and that means I have evidence for the alternative. So I have evidence that there is correlation, or there is a relationship between sales and the number of years that someone has been with the company. And again, I can't say that it's a causation. I can't say that number of years causes increased sales. In order to do that, I would need an experiment where I would need to be able to control some variables, and that would be kind of hard to do in this situation. But I can say that there is a relationship between sales and number of years with the company.